So we just spent 2 days digging into parabolas a little bit more and learning more about parabolas and their vertex and how to use them with gravity and how to do them on the calculator with regressions. To now we're going to dig into hyperbolas a little bit more. The hyperbola, remember, being that shape, just to remind you, that had 2 asymptotes like this, and then the hyperbola was in quadrant 1, typically in quadrant 3, or reflected. So that's your basic hyperbola. Hyperbola comes from division, and so what we're going to do is go back, rewind your math life to probably, when did you first learn division? I know like multiplication times tables is like second, third grade where you first learned to times. Do you remember when you first learned to divide? Really? You learned division in second grade already? Okay. I would have thought it would have been a little bit, maybe third. Okay. What symbol did you learn for division? What was the first symbol when you were little? Little dot? Okay. The divisor is what it's called. Okay, so let's talk about that. Let's rewind and back to that a little bit. All right, you learned 713 divided by 6. Something like that. Okay, so the divisor. And then how did you do that? Long division, okay? So long division turned into something like this, and you would do 716 would go under the underneath, okay? And then, 13. And then 6 would go as the divisor on the outside. And then you would kind of repeatedly ask the question, how many times does 6 go into what? 7. How many times was that? 1. But then you always had this thing left over. What did you call the thing left over? A remainder. Okay, so 6 goes into 7 once with a remainder, and we would do the long division that way. Okay. The result of this turns out to be 117 remainder 5. Okay, so then maybe you started moving into 4th, 5th grade, and you learned about fractions. And you learned that 117 remainder 5 is really 117, and not remainder 5, but 5/6 of a fraction left over. So your math world got a little bit bigger when you learned about how to do fractions. Okay. And when we say 117 and 5/6, what is the and implying? Well, there is a decimal if you turned it into a decimal, but it doesn't mean 117 times 5/6. It means add. 117 plus 5/6 is what we mean when we say and there. 117 and 5/6 means 117 plus 5/6 extra. Okay, when you write it like this, this is called a summary statement. When you write it as an addition. And the part that comes after the addition sign is called the remainder. Now you might be thinking, what in the world does this have to do with hyperbolas? But I'm going to show you. I'm going to make the connection in just a minute. Okay, so that was doing division with numbers. Can you do divisions with letters and variables? And the answer is for sure, yes. We can do division with letters and variables as well. And that kind of division is called synthetic division. Synthetic division is the division involving variables. And it results in a summary statement and a remainder. Okay, you get a summary statement at the end plus a remainder, and those have variables in them too. So let me show you how that works. And I know you've seen this before, but you probably haven't thought about it in a little over a year. Okay, division involving the variables, which results in a summary statement plus a remainder. All right, here's your first question. The variables of the problem, 2x cubed minus 3x squared minus 5x minus 10 divided by x minus 3. Regular division looks like this. Synthetic division is kind of upside down from that. Okay, synthetic division looks like this. You could curve that a little bit if you wanted, if you really wanted to make it look like the other division. All right, and the way it works is as follows. You only take the numbers. You don't have to worry about the variables. We're only going to take the numbers. So we're going to take the 2 and the minus 3 and the minus 5 and the minus 10. And so those go up here, 2, negative 3, negative 5, negative 10. On the outside goes the number that's excluded from the domain. Remember, you can't divide by 0. So what number do you have to force out of the domain for this problem to make sure we don't divide by 0? 3. Okay, because divided by x minus 3 means we need to keep 3 out. And that's what you're going to put on the outside here. It has to do with your domain. The domain is you can't divide by 3, so we're going to use it in synthetic division. Okay, the way synthetic division goes is like this. The 2 drops straight down. Then you multiply 3 and 2 together. Okay, that makes 6. And you take the 6 and you combine it with the number above it. Those combine together, which brings you down to 3. Okay, did you follow me so far? Are you remembering this, kinda? Okay, and then I start over and I take the 3 with the 3. That will give me 9. I combine that with the number above it, which gives me what? 4. Negative 5 and 9 combined is 4. And then I do the 3 one more time. 3 combined with 4 gives me 12. Combine it with the number above it, and I get 2. All right, what do you do with what's left? What do these numbers mean? All right. Well, what kind of, like, it's not a parabola. What do you call the part of that I started with, the thing in parentheses? What is that? A cubic, right? It's a cubic. It has degree 3. When you divide, the answer is going to be 1 degree smaller. And so the answer is going to be a parabola, right? A cubic divided is going to make a parabola. So what would that mean a quartic divided would make? A cubic. Everything goes down by 1. So the answer takes these numbers, and 2 is now the beginning of your parabola. You make it a parabola. And then 3 would come next. And then 4 doesn't have any variable on it at all. And 2 is the remainder. And just like you learned that you're not going to write remainder 5, but you're going to write remainder as a fraction, 5 over 6, then our 2 is written as a fraction over the original divisor of x minus 3, and our domain is all real numbers. X can't be equal to 3. This is called a summary statement. The summary statement, okay, this part of it is the summary statement. It's the result, basically. And then you've got your remainder, and you have your domain. Okay, I love teaching this because it's just so very, like, concrete. There's no word problems. It's just like we're just going to do the math, and we're going to do the problems that are going to work out this way for us. So what I want to do with you a couple times is to practice that process. Okay, each time I'm going to show you something, that might happen that you got to watch out for. So here's your second example using synthetic division. right, divide. Now division doesn't always just look like the dot division sign. Division can also look like this. X cubed minus 28x minus 48 all over x plus 4. So division could look like that, which would mean all real numbers, x can't be equal to what number? Negative 4. Which means, if I'm going to do the division, the negative 4 is the number that I start with. Okay, what's the first number that's going to go inside my division? A 1. What's the next number that's going to go inside my division? It's not negative 28. Got to be careful, because you got to go in order. And there seems to be something missing. Okay? What term is missing? A square is missing. So you need a 0 as a placeholder. That's one of those things that, oh, I forgot the 0. Okay? Last time we had a number for every position, but you need a number for every position. Then the negative 28. Then the negative 48. And then, once you've got the 0 in the position that was missing, then you can, okay, drop the 1, multiply the negative 4, which will give me negative 4. Combine, which will still give me negative 4. And then multiply again. Negative 4 times negative 4 is going to give me 16 as a positive number. When I combine those, I get negative 12. And then my last division, negative 4 times negative 12 is 48. And this time I combine them and I get 0. What did it mean when you got remainder 0 back in like elementary school math? Okay, there's no remainder because the number goes in evenly. And that meant this went in evenly as well. There was no remainder. But how do you write your answer? Well, again, you look at the power that you started with. And if you started with a cubic, then your answer has to be a parabola, has to be a squared. And so our answer is going to be 1x squared minus 4x minus 12. There technically is no remainder, but if you were forced to write one, you would put 0 over x plus 4 as no remainder. And then the domain is still all real numbers. X can't be equal to negative 4. Any questions so far? Okay, let's try another one. So each time I'm going to show you something a little bit like, so this time I was showing you about the 0. Here's another one. So don't just tune me out after one example saying, oh, I saw one example, I know how to do it, because each example shows something different that you didn't see before. So here's your next one. X to the 4th. I can't read my own writing. I think this is the fraction 1/12 x cubed. Maybe it's 1/2. I think it might be 1/2 and not 1/12. We'll go with 1/2. It's an easier number to work with. Minus 2x plus 4 divided by 2x plus 3. So the first thing you have to decide and claim is what the domain is. What do we have to exclude? Caden, can you come up with it? What's the domain for this? Okay, is it 3/2? If I put 3/2 in, I'm going to get a 6 in my denominator, which is okay. Negative 3/2 is what we need. Okay, negative 3/2 has to be excluded from that. Right, we need a negative number. If you're not sure about how to do that, trust the math. Take 2x plus 3 and set it not equal to 0. Minus 3 to both sides. And divide by 2. And then you'll have it. So if you're not sure, check the math on that. Okay, so then that means we set up our division. Negative 3/2 is going to be on the outside, and it's okay. I wanted to show you how it works with a fraction. So 1 comes first, then negative 1/2, then I need a 0 placeholder, and then negative 2, and then 4. So the purpose of me showing you this is not only the 0 placeholder, but also the chance to work with a fraction, and to see that this works with fractions too. I don't want you to be afraid of using fractions. So we're going to drop the 1. We multiply the negative 3/2. That gives me negative 3/2. And when I combine those two together, the fractions combine to make a whole number. Negative 1/2 and negative 3/2 make negative 2. You'll do the synthetic division process again, and you'll combine a negative 3/2 times a negative 2 is going to give me a positive 3. Drop that down. Multiply negative 3/2 times 3, that's negative 9/2. Combine the two of those together, we get negative 13/2. And multiply one final time. That will give me positive 39/4, which is going to give me 55/4 as my remainder. So when I write my summary statement, what am I going to lead off with? What is the lead term going to be? X to the what? X to the third. Okay, so this will be a cubic now. Minus 2x squared plus 3x minus 13/2 plus the remainder. Now you can write this a couple ways. You can write 55/4 over 2x plus 3. But that's not the most common way to write that. It's kind of awkward to put a fraction in the top. So what's probably more common that you'll see is to put the number 55 in the top and the number 4 in the denominator. That's the same thing as 55/4. 55 in the numerator, 4 in the denominator. Okay, how are we doing? So far, okay? All right. Then how in the world does this have anything to do with hyperbolas? Okay. When your summary statement is not a cubic or a parabola or anything else, when your summary statement is just a single term, just a x, that is a hyperbola. And so that's where the two come into meet up with each other. All right, so graph the summary result for the following question. And it's going to be 3x minus 7 over x minus 2. So first of all, you've got to claim the domain right away so that x is not equal to 2. And this is going to be a short and quick synthetic division because it's so small. So we can do our synthetic division pretty fast. The domain tells us that we got to use 2. And all we're going to do is a 3 and a negative 7. So this is going to go pretty quickly. We're going to drop the 3, multiply to get 6, combine to get negative 1, and we're going to write our summary statement. So what do you think I start with if my division problem started with just an x to begin with? No variable at all. The variable is completely gone. So it is just 3 plus the remainder of negative 1 over x minus 2. And that's a hyperbola. You might prefer it to be written in the other way. You might like it to have negative 1 over x minus 2 first, and then plus 3, put the 3 at the back. Either way, it's a hyperbola. You could tell me a lot about this hyperbola from what we ended up with. What does this negative tell me about this hyperbola? The word is a reflection, is what you were looking for. All right, so it tells me that I'm going to do a reflection. What does the minus 2 tell me? That is a right. And then what does the plus 3 tell me? Okay. All right, so we can graph this, so you will need some graph paper for your homework tonight. You don't need it right now, but okay. And so this thing is going to be a hyperbola shape that's moved 2 to the right and 3 up. That means my asymptotes are 2 to the right, and my other asymptote is 3 up. Okay, there's my asymptotes now. Already moved them, so I don't need Notability to like drag my asymptotes around. I already can just kind of put them in the right place. And because there's no stretch is 1, which is no stretch, but there's a negative reflection, then we know that the dots of our hyperbola are going to be going in those opposite 2 quadrants because of the reflection. And so the graph of that would then be squeezed in between those asymptotes going through that one dot. The domain of this is all we already know, all real numbers, x not equal to 2. But then our range is going to be y not equal to 3, because that's where the asymptote ended up. The asymptote ended up on 3, and so that means our range goes from negative infinity to positive infinity, but not at 3 is like sort of where it splits, it breaks the hyperbola. So I want to do one more with you, and then we're done. And then you've got 15 minutes left, and you can use that as you choose. So the last one I want to do with you is the same thing, is to graph the summary statement. So we're going to graph negative 2 minus 4x over x plus 1. So first things first, you've got to think about your domain first. So tell me, what am I excluding from my domain here? Negative 1. Good job. Okay, so we're going to set this up. Okay, be careful. Negative 1 goes on the outside. What goes on the inside first? Okay, what's the first number to list? The negative 4 has to go first. So don't get duped into thinking that the order is always the right. This order is wrong. So not only might you be missing zeros, but you might have the wrong order. And so it's important for you to get the numbers in the right order before you do your synthetic division. All right, but then we can do division after that. So we'll drop the negative 4. We'll multiply. That's going to give me a positive number. We're going to combine those, and we're going to get 2. That's the end. So our summary statement, because I started with an x, the summary statement doesn't have an x in it, so negative 4 plus a remainder of 2 over x plus 1. And I'm kind of weird like that. I like mine written the other way. It's just my brain works better when it's written in that order. But I recognize a couple things. There's no reflection this time, but there is a stretch. So I have a stretch of 2. I'm going to go left, and I'm going to go down. So I can tell that all just by looking at the result. So I'm going to go left 1, which means I'm going to have an asymptote right down the value of negative 1. I'm going to go down 4, so 1, 2, 3, 4, and I'm going to have an asymptote coming across there. And then this graph needs to be stretched by a factor of 2. And so my dot will be 2 squares or 2 units away from the imaginary intersection point, so about like that. And then we can draw our hyperbola for that. But it wasn't stretched, it wasn't reflected at all, it's just stretched. And so my domain, all real numbers, x not equal to negative 1 because of the asymptote shifting to the left, and the range, all y numbers not equal to -4 because of the asymptote dropping down to -4, but all the other numbers are included as part of the range.